Hello, this is Mrs. Westmoreland, and I'm going to talk about pages 2 and 3 in the Intro to Bonding and Ionic Nomenclature packet. So when you did this bonding inquiry activity, the top part, which was the ionic compounds, you should have noticed that all of the first elements in the compound were found to the left of the stair-step line. Those were metals. They're the losers of electrons. And all of the second elements were in the nonmetal section to the right of the stair-step line, and those would be the gainers of electrons. Then in the second half of the page, we're looking at covalent compounds. And for those, both the first element and the second element are nonmetals, including hydrogen, which, as you recall, should not be classified as a metal, even though it's on the top of column 1. So these are gainers and gainers in the covalent compounds, nonmetals and nonmetals. So in summary, we find that ionic compounds are found between metals and nonmetals, and covalent compounds are between two nonmetals. Then there's a second way of categorizing or classifying a bond based on the electronegativity difference between the two elements involved. If there's a small difference in electronegativity, it's like the tug of war on the electron pair between the atoms. No one is winning. They're shared evenly. But in a more significant difference, we have what's called a polar covalent bond, where one side is pulling the electron pair more strongly and more closely to its nucleus. And finally, when the electronegativity difference is high enough, then an ionic bond is formed because of the transfer of electrons. So you can see here that in the left-hand table, all of the electronegativity differences are greater than 1.7, and all of those would be classified as ionic bonds based on the large difference in electronegativity. They also would be classified as ionic bonds because they are found between a metal and a nonmetal. And then on the right-hand table, that set has both nonpolar covalent and polar covalent. They are all between two nonmetals, but sometimes the electronegativity difference is small, less than 0.5, which would be nonpolar covalent, and sometimes it's in between 0.51 and 1.69, and we would call that polar covalent. So compounds that contain a metal or a nonmetal and have large electronegativity differences are ionic compounds, and those that have smaller electronegativity differences and are between two nonmetals are covalent bonds. Those are often referred to as molecular compounds. So in an ionic compound, we have a cation and an anion alternating in crystals. So there's not really a single piece of matter that is defined by the chemical formula. It's really just the simplest ratio of the positive to negative charge in the crystal. We call that ratio a formula unit. In a covalent compound, however, there are actual discrete pieces of matter made up of small numbers of atoms that are called molecules. So in summary, our two types of bonds are ionic and covalent. In ionic, we have a metal and a nonmetal. In covalent, we have two nonmetals. The large electronegativity difference is found in ionic bonds, and the particles are called formula units in ionic bonds and molecules when it's covalent. Thanks for listening.